All right, geometry kids, we're going to go into section 9-9, Intro to Trigonometry. And we're just going to do the very basics. Trigonometry could be a whole year long, at least a semester long class. Doing it with the juniors right now. We're just going to get like an introduction to it. So not very deep, but we're going to learn the basics. And I think most of you are going to be further exposed to this stuff next year, whatever math class you take next year. We're going to go into right triangle trigonometry, right triangle trig. The three basic trig ratios are called the sine ratio. It's abbreviated SIN. You can even see it on a calculator. The cosine ratio, they abbreviate that COS. And the tangent ratio, they abbreviate that TAN. Sine, cosine, and tangent. And that's not sin, that's sine. And that's COS, you see that? You say cosine. You see tang, you say tangent. These are going to be used with the two acute angles of any right triangle. So the basic triangle we deal with looks like this. The basic triangle. And we learned the Pythagorean theorem off a basic right triangle like this. They call the acute angles normally capital A and capital B, and C being the right angle. And then across from C is small c, and across from A is small a, and across from B is small b. And that's where we got the a squared plus b squared equals c squared kind of idea, all right? Angle C is the right angle here. They usually use across from capital A is small a, across from capital B is small b, across from capital C is small c. The trig ratios is dependent upon how wide is like angle A and then how long these sides are, whatever numbers we put in. There's only certain combinations of angles and numbers that you can put in, and these trig ratios are based off of that. They're basically, have you ever heard kids say, was there any trigonometry? They're like, oh yeah, if you know SOHCAHTOA, you're good. SOHCAHTOA, 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 okay? It's a little way to remember what the sine, the cosine, and the tangent ratios, what they equal. It all depends on which angle you're talking about. So the sine of an angle, so they'll say angle A, or they might say angle B, is equal to the opposite leg over the hypotenuse. Opposite over the hypotenuse. So that's where the SO of SOHCAHTOA comes in. Sine opposite over hypotenuse. The cosine ratio would look like this. Cosine, and they'll say angle A or angle B or angle C. Cosine of an angle is equal to what they call the adjacent leg over the hypotenuse. And that's where the CAH comes in. Now, adjacent just is a math way of saying the leg next to it. The leg right next to it. That's what they mean by adjacent. And then tangent of an angle is equal to the opposite leg over the adjacent leg. Opposite over adjacent. And that's where the TOA, SOHCAHTOA. Sine is opposite over hypotenuse. Cosine is the adjacent over the hypotenuse. The tangent is the opposite over the adjacent. And if you're in class, maybe I'll teach you some inappropriate ways of remembering those letters. I don't want to put it on camera right now. Okay, from the picture above. So if they were to say, let's put that in there, from the from the diagram above, let's use this as an example. Quick example, anyway. From the diagram above, I would say, hey, what's the, I'm going to try to get this on the screen here. What's the sine of angle A? What's the sine of angle A? We got to think SOHCAHTOA. So here's angle A up here. If we're talking about angle A, we want opposite leg A over hypotenuse C. So that'd be small a over C. Opposite over hypotenuse. If they wanted the cosine of angle A, the cosine of angle A is going to be adjacent leg, all right, the leg right next to it, leg of the right triangle, B over hypotenuse. So that'd be B over C, the adjacent over hypotenuse, CAH, cosine adjacent over hypotenuse. Then tangent of angle A is going to be the opposite leg over the adjacent leg. So it's A over B, not the other way around. A over B. Opposite over adjacent. Opposite leg. After a while, we'll stop using leg, but it's opposite over adjacent. Opposite over adjacent. Now, that was all using angle A at the top. What if they ask the same questions about angle B? They're going to ask about one of the acute angles, either angle A or angle B. So if I did ask sine of angle B, take a minute, it would be which letter over which letter? Sine of angle B, take a look at it. It would be B over C. B over C. Opposite over hypotenuse. What's the cosine of angle B? Take a look at it. What's the cosine of this angle? And sometimes we'll put an X in there. We'll use this Greek letter theta. That's when an angle's missing. What is the cosine of it? It would be the adjacent leg over the hypotenuse. So that would be A over C. Adjacent over hypotenuse. Tangent of angle B be the opposite leg B over the adjacent leg A. So it's opposite over adjacent. And then what we're going to do is we're just going to practice writing down all these different little ratios, they call them, right? You treat them like fractions, but we treat them, they're ratios actually that we're going to be dealing with. And Pythagorean theorem does still come into play here. Get page 2 going. So let's put this application together. So think SOHCAHTOA. Keep that in mind. A lot of times when you're first doing trigonometry, not a bad idea to write it at the top. Sine is opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent is opposite over adjacent. So my example 1 will look like this. All right, and they could put X there or something like that, and they'll ask you questions similar to this. They'll say, "Hey, what's the cosine of angle A?" Or "What's the tangent of angle B?" They'll ask you those kind of questions. When you're asked something like that, one of the sides is missing. You got to fill in that missing side on your own. So you could either do the Pythagorean theorem, or since we just recently learned it, Pythagorean triple. C must equal, we could do this without Pythagorean theorem. You can go 5 squared plus 12 squared equals C squared. It's going to slow you down. You're not going to get it right. I'm sorry. You might make a mistake is what I meant to say algebraically. But 5, 12 blank is a one common right triangle. It equals 13. All right. C is 13. You got to use the 13 and fill those in. The cosine of the angle, the cosine is going to be equal to the adjacent leg over the hypotenuse. And so the answer is, if you're talking about angle A, you're talking about this angle over here. The leg next to it is 12. 5 is opposite. C is hypotenuse, 13. Adjacent leg over hypotenuse. So the answer is 12 thirteenths. 12 thirteenths. What's the tangent? Tangent is opposite over adjacent. Think TOA of SOHCAHTOA. Think TOA. So the tangent of angle B, here's angle B now. We're talking about the other acute angle. Opposite B is 12, and adjacent leg is 5. 12/5 is the right answer here. Let's keep moving. How about example 2? Let's go another common right triangle. Okay, let's see. Let's say this is A, B, C. I'm trying to think of different numbers off the top of my head. I'll leave that one blank. So you got to find the sine of angle A, cosine of angle A, tangent of angle A. Then I'm going to ask you the same thing for angle B. Hey, what's the sine of angle B? What's a cosine of angle B? What's a tangent of angle B? Some of your early homework problems will do this. They'll ask one angle, then they'll ask the other angle. You just got to keep track of which part is which. It all depends on which angle are they talking about. If we're talking about angle A, then this is opposite and 7's adjacent. 25 is the hypotenuse no matter which angle you're talking about. If I'm talking about angle B, then 7 is opposite and this bottom missing side, which is 24, by the way. 7, 24, 25, common right triangle. All right, up here was 5, 12, 13 combination. That's why we didn't have to do the Pythagorean theorem. All right, now sine of angle A, we've got to go opposite over hypotenuse. Angle A is up here, so opposite's 24, hypotenuse is 25. Cosine of angle A, now it's 7 over 25. Adjacent leg over the hypotenuse. Not adjacent meaning hypotenuse. Adjacent leg over the hypotenuse. Tangent of angle A is opposite over the adjacent. TOA. So it's going to be 24 over 7. Sine of angle B now. Now we're talking about this angle over here. The sine opposite is 7 over 25. Cosine, 24 over 25. And the tangent is the opposite over the adjacent, 7 over 24. Let's try another one. Oh, I got 2 more examples for you. Please click over to video number 2 for the last 2 examples. The second video won't take very long. I don't have much left, but I'm going to run out of time, and I don't want to be in the middle of a problem when that happens. So click over to the other one for the last 2 examples.